Volumes of Revolution, the Washer Method, Part 3. In the previous two videos, we took this region, bounded above by f of x equals root x, below by the x-axis, on the interval 0 to 4. We've revolved this about horizontal lines. In this video, we're going to revolve that region about vertical lines, starting with the vertical line, x equals 4. We're going to take a representative cross-section, which forms a rectangle. And if I were to revolve this cross-section, this rectangle, about this axis, it would form a circular disk, whose volume is pi r squared times d. Well, notice here, it's not dx like the other ones, it's dy. A clue. If you're doing volumes or other things, and the width of your cross-section is dx, everything will be x's. Your function will be x's, your limit will be x's. If the width of your cross-section is dy, then everything will be y's. Your function will be y's. Your limits will be y's. Because we're going to start making the cross-sections way down here at y equals 0, and we would continue doing that till we get to this point up here, which is y equals 2. Because if x equals 4 and y is a square root of x, y equals 2. So to find the total volume of revolution, we would sum all of these circular disks, starting at y equals 0 and going to y equals 2. The only thing missing, of course, is our radius. As always, the length of something is big minus small. Now in this case, it's going to be our big X minus our small x. So if y equals the square root of x, then x equals y squared. Plugging that in to our integral, we get that the volume is the integral from 0 to 2 of pi times radius squared dy. Before we integrate this one, we really need to multiply out this part, which will give me 16 minus 8y squared plus y to the 4th. And now we can integrate this using our constant rule. And there's some basic power rules. From 0 to 2, plugging in the top limit, then I get 2 cubed is 8 times 8 thirds. 2 to the 5th is 32, minus a lower limit, and we will leave it like that. So let's take this region, and let's revolve this about the y-axis. That is, let's revolve it about x equals 0. Notice that if we were to revolve this region here about the axis, there's going to be some empty space, which means there will be 2 radii. The big radius from the axis of revolution all the way to the far end. The little radius from the axis of revolution to the near end of the region. And then we know that our volume is going to be the big volumes minus the little volumes. We need our radii. Length, big X minus small x. Little radius, big X minus small x. And then we can find the volume. (16) because big radius is 4, and 4 squared gives me 16. Y to the fourth because the little radius is y squared, and y squared squared is y to the fourth. Finding our antiderivatives. I'll factor out the pi now like I usually do. And we get that volume.